When we talk about infrastructure as code, or IAC, it helps to start with the basics. Infrastructure, at its simplest, is the foundation that applications run on: servers, storage, networks, and all the supporting services. Traditionally, these were managed manually. Clicking through cloud consoles, writing shell scripts, or even handling physical machines. That worked for small setups, but as systems grew, manual infrastructure became error-prone, inconsistent, and slow to scale. This is where IAC comes in. The key principle is declarative configuration. Instead of manually describing steps to create infrastructure, you write code that declares the end state you want. For example, VPC with 3 private subnets, an EC2 instance, and a load balancer. The IAC tool figures out how to create and maintain that state. This approach is powerful because the code is now version-controlled, peer-reviewed, and testable just like application code. At its core, IAC solves 3 main problems: consistency, repeatability, and automation. Consistency. Every environment development, staging, and production can be spun up identically from the same code. Asterisk, asterisk, asterisk repeatability. Asterisk, asterisk. You can update and recreate infrastructure without worrying about forgetting a manual step. Automation, infrastructure changes can be part of your CI/CD pipelines, ensuring that deployments are predictable and reproducible. Now, there are 2 common approaches to IAC: declarative and imperative. In the imperative style, you explicitly define the steps to provision infrastructure. Think of it as saying, first create a VPC, then add a subnet, then attach a route table. Tools like Ansible sometimes lean this way. In the declarative style, you only specify the desired outcome. I want a VPC with these properties. Tools like Terraform and CloudFormation handle the how for you. Declarative IAC is more common in cloud-native DevOps because it simplifies maintenance and reduces human error. Let's get into the tools. Terraform is cloud-agnostic. It can manage AWS, Air, GCP, Kubernetes, and even SaaS providers. It uses a language called HCL, which is designed to be readable but also expressive. One key concept in Terraform is state management. The state file is a snapshot of what your infrastructure looks like. Terraform uses this state to calculate differences between what's currently deployed and what your code describes. This is why Terraform can show you an execution plan before making changes. AWS CloudFormation, on the other hand, is AWS native. You define infrastructure in JSON and RYAML templates, and CloudFormation provisions everything for you. It integrates tightly with AWS services like IAM for permissions or Coda Pipeline for automation. It also has features like change sets, which allow you to preview updates before applying them. And drift detection, which checks if your deployed resources have drifted from what's defined in code. Now, let's see how IAC fits into a typical DevOps workflow. First, you might have an engineer open a ticket or a PR to make some change. Maybe it's a new web app in AWS or a database in Azure. This change is implemented as code, usually in the form of Terraform or CloudFormation templates. These templates define the target infrastructure. Next, the code is validated. This could include linting to check syntax or running a static code analyzer to find potential issues. The IAC tool often has a command like plan or preview that shows you what will be created, modified, or destroyed. If the plan looks good, you apply the changes to your target environment. This might happen automatically in a CI/CD pipeline or with direct developer intervention. In a true DevOps flow, the infrastructure code is integrated with your application code in a single repository. This promotes a consistent and collaborative approach to development, making it easier to track changes and roll things back if needed. Finally, once your infrastructure is deployed, monitoring and logging come into play. You want to observe how your infrastructure is performing and detect anomalies or errors. Tools like Datadog, Prometheus, and Splunk help you collect and analyze metrics from your cloud providers. They alert you when something goes wrong and provide insights into how your systems are behaving. In essence, infrastructure as code transforms how DevOps teams work. It moves away from manual, error-prone processes towards a repeatable, automated, and auditable system. Whether you use Terraform, CloudFormation, or other IaaC tools. The benefits are clear. No more Snowflake servers, no more tribal knowledge locked in one engineer's head, and no more guessing what changed in production last night. Instead, infrastructure changes are documented, reviewable, auditable, and most importantly, reproducible. If you enjoyed this video, please hit like and subscribe for more cloud-native content. Thanks for watching.